6-3 and 6-4?
Because it's still.
We already did 6-3. But you skipped 17 and 29 and another one, right? 39? Why did you skip them? Well, let's see. Here we go. Ready? Okay. Remember, if you're bored, you can have your 18 number 12 out and be working. But shush, 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 shush. Okay, here we go. Number 1. U equals, come on, amazing ones. You've done this so much. U equals what?
1 minus 4x squared.
So I can zoom ahead and say du dx is equal to negative 8x, and then I can go ahead and say that dx is equal to du over negative 8x. Are we good?
Yeah.
Then we go plugging and chugging, right?
Yeah.
And when I go plugging in, well, hopefully things cancel, right? So I have x over root u times du over negative 8x. Yay, x's are gone. And now the only extra thing I have is a negative 8. And what can happen to that negative 8? Pull it out, but it's a 1/8, right? Because it's in the denominator. Now, some of you would say 1 over root u. Use an ln, and I say no, because what is 1 over root u? U to the negative 1/2. Don't forget, if it's in the denominator, you can make it a negative power. And the only negative power I have to watch out for is negative 1. Good. Now I can say power rule, got that, right? I add 1, I get positive 1/2. Divided by positive 1/2 is like times 2. Then I can go ahead and say negative 1/4. What's u? 1 minus 4x squared plus c. Who has it? Let me see hands. Catherine, what was your question?
Why don't you take the square root when you're doing u? Why do you just do the what's in the square root?
Because if I did do a square root, my du dx would be 1 over 2 square root of times. It's not going to go canceling out nicely. Okay, I know we're excited because hopefully we just like busted through that one. Question, what if we were like, got it, it's the exact same dealio, and I say u equals 1 minus 9x squared, du dx is equal to negative 18x, therefore dx is equal to negative 18, nope, that's, forget that, sorry, du over, Jezreel, negative 18x, and then I go plugging and chugging, and I say, okay, integral of 1 over root u, look, it's just the same. But what's wrong?
X doesn't cancel.
Well, no big deal. I pulled a negative 18 out, so just pull the x out.
Plus
Can you pull an x out of an integral? Why not? The only rule is the constant rule, and the constant rule says, yes, you can pull out the 1 over 18, but I'm still stuck with, am I allowed to integrate if I have 2 different variables in an integral? No. Right? So therefore, oh, well, we did this whole integration on crafting, right? And it's like, no big deal. Take your u and say, hey, who's x? Right? Yeah. So x is equal to u minus 1 divided by a negative 9. 1 minus u divided by a 9. Square rooted. Now what? Plug it in, plug it in. So then I say, psh, got this. All right, fine. It's nasty, but whatever. It has to be a possible problem, right? So negative 1 over 18 integral of 1 over root u times du over root 1 minus u all over 9. Then you can say, I need it to fit a rule. So let's see. Square root of 9 is a 3. I can pull the 3 out and I get, well, 3 goes on top or divided by 3. Either way, 1/6. Integral of 1 over root u times root 1 minus u. Well, I guess we could bring that in, maybe. Well, let's leave it out. Du. Now what? What's the dilemma? I'm trying so hard, aren't I? But where am I going? Going down the rabbit hole. And that Hatter's going to be like, so we're done. Guess what? My u was wrong. My u was wrong.
No way.
If we're going down a rabbit hole, either your math is wrong, but mine wasn't, or your u was wrong. So, what if we were to make the u square root of? And du dx is equal to, do we remember derivatives? Take down the 1/2, make it a negative 1/2 times u prime. That's looking not better at all. We chose the wrong u. Nope.
There is no u.
I'm just telling you the u, and we'll figure out why in a second, but the u is 3x. Stop. Pause. Rewind. We'll come back in a second. I want you guys to do the following review problem. Review. Review. Come back. I want you to derive sine inverse of 3x. Go. Come on. Do you know your forevers?
Yes.
Come on. Come on. What's the derivative? Come on, do a derivative. How do I do the derivative of arc sine or sine inverse or whatever?
1 over.
1 over.
1 minus u squared. Yeah, so all 1 minus.
Does this maybe put a new light on what we were doing? Because from every derivative rule, what do we get? An integration rule backwards, right? So I can say, according to this, well, multiply by dx. Oops, that's not a y. Every derivative rule is an integration rule backwards, right? So what did I mean by guys, what was the difference between number 1 and number 2 that made number 1 so easy and number 2 so not? There's an x on top, and I needed him for u prime, and he canceled out so prettily on the first one, and the second one said, right? How can I rewrite this if u is 3x? Well, wait, hold on. Du dx is equal to 3. Dx is equal to, I'm not saying where I got it, I'm just saying it's true. And asking you to go on faith for just a little bit. Then we go plug in. And when we go plug in, we get, this is the integral of 1 minus, divided by square root 1 minus, what is 9x squared in relationship to 3x? Hopefully just a second ago I made you recall the inverse trig formulas, and so when you see 1 over 1 minus u squared du, it's like 1 over square root of 1 minus u squared u prime, which takes us back to where? Takes us back to where? Inverse sine. Arc sine, inverse sine, both the same dealio of u plus c equals 1/3 sine inverse of 3x plus c. Dun 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 dun. Stink. Why is inverse trig gonna be a bit difficult? It's hard to see. For the very reason that the derivative was so weird, because the derivative of an inverse trig took us to a triangle, and we did like ratios, and we used the derivative of an inverse. I was going to show you, and I decided not to. We already did last semester. An inverse trig has a derivative of nothing trigonometric whatsoever. And so I'm going to have an integral with no trig whatsoever that can only be answered by. So let's talk about him for a second. Here we go. 1 and 2 and 3, you don't need any spaces. I just spread them out because they're messy. Wait a minute. Whoa. whoa, 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 whoa. Does this look like this?
Yes.
Wait.
Kind of, but what's weird?
A. What's A?
We'll see. Write down the rules first. There are two strategies. There are two different, I don't know, can I really say like ways of thought on this? I don't know. There are two different approaches to inverse trig. One says memorize a harder rule but make the process easier. One says make the process harder but memorize an easier rule. I'm going to show you both and you get to choose what you want to do. I'm having you write down this one because it simplifies the process. It simplifies the algebra, even though it makes the formula more complicated. It simplifies the algebra even though it makes the formula more complicated. I don't know if I really need to explain my rationale, but long story short, I figure you have to memorize stuff anyway. So why not have you memorize the more complicated one and hopefully make fewer silly math mistakes. But some of you are like, I got the algebra. All right, you can memorize the easier formula. But just be careful. Josh. Why is there no arc cosine, arc cosecant, or arc cotangent? They're just a negative. So technically, if I have a this and I go to a this, it'd be the same thing as negative arc cosine. But AP guys, in my experience, never go back to arc cosine or arc cosecant or arc cotangent. Never go back. They might have you take a derivative of one. I don't think I've ever seen them go back to one. Which is why there's only 3, not 6. This is forever number 43, 4? Sure?
Positive.
Cool. Negative?
Negative 44?
Just kidding.
Be nice.
If positive is sure, does negative mean unsure? Interesting. Anyway. Okay. Can I show you where the 8 comes from? Is that okay?
Yeah.
Let me give you the following example. I'm actually going to steal him and we'll do him the easy way in the next example. Got it. Okay. What if, example, I was to give you the integral of 1 over 9 plus x squared dx. Hold on, pause. Focus. There we go. So, 1 over 9 plus x squared. Why not u sub, pick the whole denominator like we've been doing like nonstop? Because if u is 9 plus x squared, what would du dx be? 2x. And what's not going to cancel? The x's won't cancel. The 2 I could deal with, right? But the x, not a good deal. So u sub, nope, not the way that you're used to. Guys, which of the arc trig formulas, if you just think about like arc tangent derivative, arc sine derivative, arc cosecant or secant derivative, which one matches this the closest?
The last one.
Not the last one.
Yeah.
Arc tangent. If I take the derivative of tangent inverse of x, I get 1 over 1 plus x squared times u prime, but it's just 1. What's different between that and this? There's a 9, which you could think of as an a squared. If you wanted to memorize an easier integration rule and say, hey, the integral of 1 over 1 plus u squared du is equal to tangent inverse of u plus c, you could, but the problem is to use this one that doesn't have an a squared, you have to always get this to be 1. Uh-oh. You'd have to do some funky algebra. Wait, is it true? It is, right? But then I have to, well, okay, I could take out the 1, 9. But then I have to think about, wait a minute, who's been squared? No. Who's been squared? X over 3. So question. I could do this every single time and I could say, yay, u is what? Du dx is equal to, not quotient rule, it's just 1/3 x, so it's 1/3. So then dx is equal to 3 du. Then I could go plug in and chug in and I could say, this ends up equaling 1/9 times the integral 1 over 1 plus u squared times du times 3. Bring out the 3. 3 over 9 is 1/3 integral of 1 over 1 plus u squared du. Hey, that leads me to arctangent, 1/3 tangent inverse of u. And who is u? 1/3 tangent inverse of 3x. No. I'm in a future example or a past, I don't know. Plus c. I'm just going, I don't know. There we go. Or, are you seeing the simple rule though? Wait, guys, okay, you could memorize a simpler rule with no A's and just say, I gotta get it to be a 1. Go, gone. Okay? Or, look at your rule. Look at what you wrote down in forever number 44. I could say A is what? 3. And U is X. A squared plus U squared. So I could do this entire problem just with my forever card and say, hey, so now I'm thinking about an A, and an A is A squared, that's a 3. U is the square root of, that's an X. Du, well, sorry, the old way, no, the new way, is 1. Therefore, dx equals du. And I can use my forever card and just say, got it. Plug it in, I get 1 over A squared plus U squared du. Hey, that fits my formula. So 1 over A tangent inverse or arctangent of u over a plus c. Do both ways work? One, you memorize a harder rule, but your math is easier in solving. One, you memorize an easier rule. Your math is harder. Kiddos, number 2, what is u? You have your forever card, use it. What's u? 2. There you go. How'd you see it, Jezreel? Square root of 1 minus who squared? Who squared? 2x squared, right? So therefore, if I let my u be, guys, what rule am I trying to use? Inverse sign, good. What's A? Oh! Don't even have to worry about them. Not root. Well, okay, yeah. Just be careful. You're not killing puppies, right? You're looking at the one, seeing him as a square root, and saying who's a square root. Okay. So then I can say 2. He comes out. And then I get 1 over square root of 1 minus u squared. Well, if you want to think about the 1 as a squared, sure. A squared minus that looks like a 9. Struggle. A squared minus u squared. Du over 2. What happens to the over 2 and the 2? I could pull out a 1/2. They reduce parts that we're tracking, right?
Right.
Equals, how do I write my answer? It's arc sine. So it's sine inverse or arc sine of u, which is 2x, over a, which is just over 1, plus c. Is this too bad? No. You just have to look at problems with a more critical eye. Especially when you have a square root in a denominator or something squared in a denominator. Cool kids, be amazing. Number 3. Show off. Come on, focus, go. What's u? It's okay. Take a second.
3x.
Look at your rules. Nice.
Is that right?
Negative 4 plus 9x squared? Nope. I mean, you can, but that's not going to help you get any closer to a rule, because the rule you should be looking at is, everybody, which one? Arc Get the rules. I don't want arc sine. I want arc secant because this looks a lot like u square root of u squared minus a squared. Remember, arc sine goes number minus arc secant goes variables minus numbers. Kiddos, this is just the tip of the iceberg, so please hang with me. U equals what? Okay, we're a little bit past the tip, but whatever. It's not the whole thing. U equals what? 3x. So I can say du dx is equal to 3. So I can say dx is equal to du over 3. Up, front seat, go now. Everything. Okay, now plug it in. Wait. What else is new?
The outside part.
U's, du's, and a's. What's a? 2. Now, hold on. Can anybody see how this could get harder? What if that wasn't a 4? What if it was a 5? Square root of 5. Okay. Just going to look nasty, right? So then, subbing, I can pull out a 4. Do I want to pull out the 3? I think I want him to stay. Does that make sense? And then I'm going to plug in my du over 3. Nick Davis, go ahead, kiddo.
If a was negative, would that, because I mean it's squared anyway, and it would be positive in the formula, but I don't see why. And would that change the answer?
If a was negative, what would that change? For tangent inverse, you'd have a negative on the outside and a negative on the inside. Tangent is odd, so a tangent of a negative would be negative tangent of a positive. The negative would come out. It's the same thing. For sine, I don't have a negative on the outside. I have a negative on the inside, but sine is odd as well, so therefore sine of a negative would be negative sine of a positive. Cosine of it would be even, so it would stay the same and it wouldn't matter. It would still be negative on the outside. Secant is 1 over cosine, that's even. Secant wouldn't matter, wouldn't make a difference.
Oh.
But the nice thing is for us, we can just say a is always going to be the positive square root of. Because we're not actually doing the math of taking the square root of. Instead, we're seeing it as, that was a good question though. A is always going to be a positive. I have to think about sign more, because that would be an odd and that would flip the sign. Tangent's easy though. I'll keep thinking about it. Guys, with the 3, what can I do? Pull it out, right? And then I have, hey, it's a perfect rule. So therefore, this is arc secant, or secant inverse of, wait, how's the rule work? 1 over a, who's a? 2, times secant inverse of u over a plus c. Some of you guys, the c's, you're not really seeing why. Anyway, why they're remaining c's sometimes and not other times. But guys, if I distribute, all right, fine. 4/3 and 1/2 is going to be 2/3. Secant inverse of 3x over u over a. Why is it just plus c and not plus 4/3 c? Because a constant times 4/3 is a new constant. Whatever. Carson.
So the a would never be negative, so even if we had root 9x squared plus 4, it'd still be 2. Even though
But that wouldn't fit my rule. I need u squared minus a squared. So I think that would be a u sub in the normal sense, hopefully. There is something called trig substitution. It's a Calc 2 technique that could solve that, but you wouldn't know how to do it. No, you wouldn't know how to do it. No, oh wait, hey guys, what was the title of this page?
straightforward.
Bravo.
Uh-oh.
Those are the straightforward ones. How about this one? Oh, that's u sub, like in the normal sense. U is just going to be t to the 4th plus 16, right guys?
No.
It's the whole denominator. And then du dx, I know you told me no, but I'm still going, 4t cubed. And that's a t. So then dt is going to equal du over 4t cubed. And I plug him in and I don't cancel everything. I'm going to have a t squared and that's not going to be fun. So that's not a good idea. But wait, there was a t up top. But was it enough t's? Nope. So our trig. What's my u? T squared. Nice. Do you see it? What's my a? What's my du dt? 2t. So then my dt is du over 2 times t. So is this going to work out quite nicely even though there's a t up top? Is it good? Golden, right? Because then all I have to do is say, hey, over 2, that's a 1/2, and now he fits perfectly, arctangent, right? Arctangent, how's the formula work? 1 over a, if you're doing the complicated way. Complicated formula, easy solve. Of u over a. Plus c. But as we just saw, the plus c, well, whatever, he still remains a plus c, so I can just say 1/2 times 1/4, which is 1/8 tangent inverse of t squared over 4 plus dun 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 dun. If you get it, if you got it, good, go. Number 5. Bust it out. He's a little more hidden. He's not a lot. Wait for number 6. You have a new way of looking at integrals with denominators. Doesn't mean you always use inverse trig. Sometimes there's no other way. If you look at your forever number 44, if you're still not, if your brain hasn't grasped the inverse trig, look at forever number 44. You guys notice it's 1 over, so I don't think it's going to be u sub. Not in the traditional sense of pick the whole denominator. Giving you 15 more seconds, and then I'm coming. It's been 15, right? My turn. Dun, 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 dun. Did you get there?
Yeah.
Questions?
What's number 6?
That was a good one. Best reaction of the day, although honors pre-cal almost had one close to it. People already know about it. Shh, don't really know. Are we good? Are we ready? Arc trig. Why not u sub?
Because 1.
Why not u sub in the normal sense? If I just pick the whole shabam and say, psh, it's the whole denominator, duh. And then I have du dx equals 2x minus 6. Is that going to go very well?
No way, dude.
So what? How? Huh? And then I take the middle and I cap it and I square it and I say, what? I'm completing the, and then I have to offset it. There's a plus, there's a minus, and I say, and then all of a sudden, now I can say, ooh, that's going to be, what? There's a purpose for that? What I just do, who just returned? The return of?
Don't say it. The return. Don't do it.
partial fractions. All right.
Oh no.
Just kidding. That's Dalton.
Oh,
It's kind of fun though. Let's not say we didn't. Okay. Totally keep going, because now when I use completing the square, I can be amazing and say, what is u? Who would have thought that way back here? Not many of you. X minus 3? What?
I see.
But now, x minus 3, of course. A equals 2. Du dx, column it, equals 1. That's okay. It was more the weirdness. Plugging in. Dun, 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 dun. Just in case you're curious, technically I could have also written it like that. But I think, as I just said, AP guys, as far as I have ever seen, would say that instead. Is this page a little more hidden? Little? But did we make it? Do I want that one? Ooh, that's fun. Not as fun as today, though. Guys, be amazing. You don't even need arc trig, I don't think. But can you just, one more time, maybe I'm trying to keep something in there for once. Just kidding, a lot of things escape though too. Solve me the differential equation such that y of 1 equals 2. Go. Be amazing. This should be easy stuff. Child's play. Maybe even a pre-calc kid now. Maybe a first semester AP? No, maybe not. But you guys can. Look at this, we're getting fluent in calculus. So far. Okay guys, AP number 12. Can you be working on that? Mm-hmm. Are there integrals in there? Mm-hmm. Can you do them? Most of them. If not all of them. I'm not giving you BC ones, I'm giving you A to B ones. There might be a couple processes that you're not quite sure about yet, but the integrals, pretty much, we're done with rules. Pretty much, we're done with integration rules. Couple more processes, couple more processes. That sounds great. Couple more applications, but Can I start? Can I have fun now? I don't know, I was just making it pretty. Are we good?
Yeah. Yeah.
Yay! Thanks, guys. That was good. Are we okay? Remember, cube root 1/3, 1/3, add power. Sorry, add 1, divide by. Add 1, add 3/4. plug it in, solve. Wasn't even inverse. Man, tonight might not be all inverse. I don't remember. Was it? All inverse? Mostly. Mostly. Maybe a few review ones just to make you feel good. Kiddos, there's homework. If you want to take a picture of it, it's also online. It's 17. Wait! It's